Okay, let's look at sketching the graph of a rational function. So if we want to graph a rational function, you have to be able to identify all the different asymptotes as well as all the intercepts. So you can start by finding your vertical asymptotes. So when we're finding our vertical asymptotes, we take our denominator and we're going to set it equal to 0. Before we can do that, you have to make sure if one of your your function factors, you need to go ahead and factor it, because if one of the factors cancels, we do not use that to finding vertical asymptotes. As you can see, the bottom here, it's a differences of square, so it's going to factor into x minus 2 and x plus 2. As you can see, we have x minus 2 on top and bottom, so it's going to cancel. So we're only left with 1 over x plus 2. So the only one we're focusing on for vertical asymptotes is the denominator of x plus 2. So we take x plus 2 and we set it equal to 0. Then we go ahead and solve for this one. So we end up with x equals negative 2. So that means x equals negative 2 is going to be one of our vertical asymptotes. So remember, we're going to graph it with the dashed line, and we cannot cross x equals negative 2. So now to find our horizontal asymptotes, this is just using the 3 rules. And by using the 3 rules, you're focusing on the powers of your top and bottom. So go back to your function and look at the degree on the top. The degree on top is equal to the highest power on x is 1. The degree on the bottom, the highest power on the bottom now is 2. And then we have to make the conclusion. Are our degrees equal? Which one's bigger? So as you can see here, the degree on top is actually less than the degree on the bottom. So when your degree on top is less than the degree on the bottom, I meant to put a B for bottom, we make the conclusion that our horizontal asymptote is the line y equals 0. So we end up with the equation y equals 0. From here, you have to, the other type of asymptote is your slant asymptote. But in this case, remember, in order for us to have a slant asymptote, your degree on top has to be 1 more than degree on the bottom. In this case, we don't have to worry about that, so we can move on. So we have 2 pieces of information so far. The next piece of information will come from finding your x-intercept. So to find your x-intercept, we know our y is 0. In this case, we're dealing with a rational function of f of x equals p of x over q of x. So the trick is, for finding your x-intercept, is you only worry about the top part. So we only worry about p of x, and we set p of x equal to 0. So our p of x, in this case, the top is x minus 2. We set it equal to 0. So we're going to have an x-intercept at the value of x equals 2. But let's recall this from the first step here. Because x minus 2 cancel out, it created a hold. So when we solve for x minus 2, that means we're going to have a hold at x equals 2. So I know it says we're crossing the x-intercept at x equals 2, but it's going to be an open circle. We cannot cross our at x equals 2 because it creates a hole, so it's undefined. So now we need to find our y-intercept. So by finding our y-intercept, we're letting our x be 0 now. So we go back to our function. Everywhere we see x, we're going to go ahead and plug in 0. So we end up with negative 2 over negative 4, which simplifies to 1/2. All this piece of information is not enough to graph our function, because let's go ahead and just graph whatever we have. So far we know we have a vertical asymptote at x equals negative 2. So we draw it with this dashed line, this vertical dashed line at x equals negative 2. And we know we have a horizontal asymptote of y equals 0. So that means your x-axis is actually our horizontal asymptote. And we know we're crossing the y-intercept at the point of 0, 1/2. So at 0, 1/2, let me put some points in here. So at 0, 1/2, we're crossing our y-axis. In this case, recall how we said that the x-intercept put us at x equals 2, but look at our x-axis. Our x-axis is actually our horizontal asymptote. That's why it created a hole, so we can't use it for our picture. So out of everything we just did, all we have on our graph is one dot. We need more than that to be able to graph it. So you have to create, it looks a little bit busy, but if you don't mind, I'm going to put an x and f of x table right here next to this. So you need to be able to fill in any gaps to be able to connect your picture. So you look at your vertical asymptotes and you want to make sure you know what's going on to both sides of your vertical asymptote. So I want to know what's going on this side, so I'm going to go ahead and pick the value of -3 and -4. I want to know what's going on this side, so let's go ahead and pick the values of -1, and you can go ahead and pick the value of 1. You're going to take these x values and plug them back into your original function. So when we plug this back into here, we're going to end up with -1, -1/2. We're going to end up with 1. And we know we had 0 is 1/2. If we plug in 1, we're going to end up with, and I'm just literally plugging in back to my function. So everywhere you see x, we will plug in 1. So it will be 1 minus 2, 1 squared minus 4. So that's how you end up with -1 over -3. So it becomes a positive 1/3, as you can see. So plug in your points. -3, we're down at -1. -4, we're down at -1/2. So we don't cross asymptotes. So as you can see, we're going to be getting closer and closer to our asymptotes, but we're not going to cross them. Over here we have -1. We're up at 1. At 1, we're actually very, very close. 1/3 is about 0.333, so we're somewhere down here. So same thing here. We're going to get closer and closer to our asymptotes, but we're not going to cross our asymptotes. So that's the graph of our rational function of x minus 2 over x squared minus 4.